Introduction. Under-reamed pile foundations are specialized deep foundations used predominantly in expansive or problematic soils where conventional shallow footings are not safe or economical. They are particularly beneficial in areas affected by seasonal moisture variations, such as regions with black cotton soil, which tend to swell during monsoon and shrink during dry seasons. An under-reamed pile is a board cast in situ concrete pile featuring one or more enlarged bulbs reams formed at a specific depth. These bulbs significantly enhance the bearing capacity of the pile and improve its resistance to uplift and lateral forces. This type of pile foundation is extensively used in residential buildings, water tanks, transmission towers, and other light to medium structures that rest on unstable ground. The design and construction of under-reamed piles are governed by the Indian standard IS 2911 Part 3. This video will walk you through the advantages, applications, dimensions, IS code design guidelines, and construction procedures. Whether you are a civil engineering student, site engineer, or designer, understanding this technique is essential for ensuring stability in adverse ground conditions. Let's begin with why under-reamed piles are a preferred choice in many foundation systems across India. Advantages. Under-reamed piles are known for their efficiency, stability, and economy in expansive soil conditions. The major advantage lies in the enlarged bulb at the base, which significantly increases the bearing area, enhancing both vertical load capacity and uplift resistance. These piles remain unaffected by seasonal soil movement, preventing cracks and differential settlements in the superstructure. They require less concrete and steel compared to conventional deep foundations, making them cost-effective. The bulbs anchor the pile firmly, making them ideal for structures exposed to wind loads, such as towers and elevated tanks. The construction method is relatively simple and fast, especially using mechanical under-reaming tools. They also offer better seismic performance due to their depth and anchorage. Moreover, under-reamed piles are environmentally friendly, as they minimize excavation and require less space for foundation work, making them suitable for dense urban areas. USES. Under-reamed piles are highly effective in areas where soil undergoes volumetric changes, such as expansive clay soils. Their primary function is to anchor structures in stable strata below the zone of seasonal moisture variation. They are commonly used for residential and commercial buildings in black cotton soil regions, water tanks, overhead tanks, and communication towers, industrial sheds and machine foundations with light to moderate load, power transmission towers, where uplift due to wind is significant, boundary walls, especially in undulating terrain, seismic zones to reduce movement-related failures. Additionally, under-reamed piles are used in retrofitting existing foundations and for structures built near riverbanks, coastal regions, or low-bearing capacity soils. Their adaptability to a wide range of structures and simplicity in construction make them a preferred foundation type across various civil engineering projects in India. Design guidelines as per IS code. As per IS 2911 Part 3, 1980. The design of under-reamed piles must consider the type of soil, structural loads, and depth of seasonal influence. Number of bulbs. 1 to 3 bulbs can be provided per pile. The number is determined based on uplift forces, soil type, and design load. Bulb diameter should be 2 to 2.5 times the pile shaft diameter for effective bearing and anchorage. First, bulb depth. Placed at a minimum 2.0 meters below ground level, ensuring it is outside the seasonal moisture variation zone. Concrete mix. Use a minimum M20 grade concrete with proper workability and durability. Reinforcement. High-strength deformed bars with minimum clear cover of 40 millimeters. Lateral ties should be provided at closer spacing near the bulb. Factor of safety FOS. For structural design, FOS should be 2.5 for ultimate load capacity. Pile length. determined through geotechnical investigation and structural analysis, depending on soil-bearing strength and imposed loads. Quality checks. Each pile should be tested through initial or routine load testing to verify assumptions. These guidelines ensure the long-term performance and safety of structures using under-reamed piles. Dimensions of under-reamed piles? The dimensions of under-reamed piles are governed by IS 2911 and optimized for load transfer and stability in expansive soils. Pile shaft diameter typically ranges between 200 millimeters to 500 millimeters, depending on the design load. Bulb diameter is kept to 2.5 times the shaft diameter. For a 300 millimeter shaft, the bulb may range from 600 millimeters to 750 millimeters. Pile length varies from 3 meters to 10 meters or more, based on load requirements and soil depth. The pile should extend beyond the active zone of seasonal moisture change. Number of bulbs, maximum of 3. The most common configurations are with 1 or 2 bulbs. Bulb height is about 1.5 to 2 times the shaft diameter, generally between 450 millimeters and 750 millimeters. These dimension guidelines ensure efficient load bearing, cost effectiveness, and safe construction under challenging geotechnical conditions. Spacing between bulbs. When multiple bulbs are used in a single under-reamed pile, the vertical spacing between consecutive bulbs must be at least 1.5 times the diameter of the bulb. This spacing ensures that the stress zones created by each bulb do not overlap, maintaining their individual load-bearing efficiency. For instance, if the bulb diameter is 600 millimeters, the minimum spacing between bulbs should be 900 millimeters. The number of bulbs is generally restricted to a maximum of 3 for practical construction and load transfer. Following this spacing guideline ensures improved anchorage and reliable performance under vertical and uplift forces. Diameter of the bulb, as per IS 2911 Part 3, 1980. The diameter of the under-reamed bulb is typically 2 to 3 times the diameter of the pile shaft. For standard practice, a bulb diameter of 2.5 times the shaft diameter is commonly adopted. For example, if the shaft diameter is 300 millimeters, the bulb diameter will generally be around 750 millimeters. The minimum spacing between 2 bulbs should not be less than 1.5 times the bulb diameter. This enlarged bulb improves load-bearing capacity and provides enhanced resistance against uplift and lateral loads in expansive soils. Spacing of piles. According to IS 2911, the minimum center-to-center spacing of adjacent under-reamed piles should be at least twice the bulb diameter. This ensures adequate soil mass between piles to resist overlapping stress zones and to facilitate easy excavation and concrete pouring. For example, for a bulb diameter of 750 millimeters, the spacing between piles should be at least 1.5 meters. Reduced spacing may be adopted in dense pile groups, provided group action and interaction effects are considered in the design. Adequate spacing is vital for the proper performance and constructability of the pile group. Load carrying capacity of piles. The load carrying capacity of under-reamed piles is calculated based on both end-bearing resistance from the bulb and skin friction along the shaft. The Indian standard IS 2911 recommends analyzing both to determine the safe design capacity, end bearing. The enlarged bulb rests on firm strata, providing high end bearing strength. Skin friction, developed along the shaft, especially effective in cohesive soils. Typical safe load capacities are 300 millimeters dia with single bulb, approximately 25 to 30 kilonewtons. 400 millimeters dia with 2 bulbs, approximately 40 to 60 kilonewtons. 500 millimeters dia with 3 bulbs, approximately 75 to 100 kilonewtons. Design should apply a factor of safety of 2.5 to the ultimate capacity. Capacity also depends on soil strength parameters, pile dimensions, and depth. Verification by load testing is recommended for critical projects to ensure actual field performance. Design guidelines for capping beams. Capping beams distribute loads from the structure evenly across the connected piles and provide stiffness to resist differential settlement. Design considerations include material, reinforced concrete, minimum M20 grade, width, generally 300 millimeters or more based on pile spacing, depth, equal to or greater than pile cap thickness, adjusted per structural needs, reinforcement, main bars at top and bottom with appropriate stirrups for shear, clear cover, minimum 40 millimeters to protect against corrosion. Capping beams should be designed to handle bending moments, shear, and horizontal loads, especially in seismic zones. Dowels or shear keys can be used to improve connectivity between piles and beams. The beam must be cast monolithically with pile heads, ensuring uniform load transfer and integral behavior under structural forces. Proper detailing and anchorage ensure long-term durability and safety. Design guidelines for pile caps. Pile caps are thick reinforced slabs that bind multiple piles and support the column or wall load. Shape: square, rectangular, or trapezoidal depending on pile arrangement. Reinforcement: placed in both directions at top and bottom layers to resist flexural and punching shear. Cover: minimum 40 millimeters for corrosion protection. Pile cap should extend beyond the outermost piles by at least 100 millimeters and integrate with the column reinforcement. Adequate development length and anchorage of bars must be ensured. Detailed design per is 2,911 and is 456 is essential to handle structural loads, resist cracks, and ensure proper distribution to the pile group. Construction of under-reamed piles. Construction of under-reamed piles follows a systematic procedure to ensure quality and performance. 1. Layout and boring. Mark pile locations and drill vertical boreholes using manual or mechanical augers to the required depth. 2. Bulb formation. Use a mechanical under-reaming tool to create one or more bulbs. Check bulb diameter and depth per design. 4. Reinforcement. Insert steel cage with adequate cover. Ensure proper tying of longitudinal bars and spirals or lateral ties. 5. Concreting. Use tremie or chute method for concrete pouring to prevent segregation. Fill the pile from bottom to top in a continuous pour. 6. Curing and trimming. Allow concrete to cure adequately. Trim pile heads to the designed cut-off level before casting the pile cap or capping beam. Strict quality control, supervision, and periodic testing are essential throughout the process. Field load tests help verify design assumptions. Under-reamed piles, time-tested foundation solution in India's problematic soils. Designed correctly as per its code, they ensure safety, stability, and economy. If you found this video informative, don't forget to like, comment, and subscribe to Civil Engineering Edge for more deep dive tutorials on foundation design and construction technology.